Now that this is set up, let's go ahead and put this on our, diving inside here, put this on our primitive that's waiting for us right here. So I'm going to put down another attribute, VOP, and we'll plug this into the first input, and then our incoming primitive into the second input. And I'm just going to call this place on prim. Well, on prim, that should be fine. Okay, let's go ahead and dive into here. So there is a VOP for us, which we need to use. I'm going to start typing primitive. And then we have a VOP here called a primitive attribute. So we're just going to put that right here. And essentially what that allows us to do is put in those UV coordinates I was talking about for a primitive between 0 to 1. And then it's going to find some interpolated data on that primitive and output that for us. So actually what I want to get is the position. I want to know where in this space do those UV coordinates coincide? Where do they, exactly, what do they stand for? Where should they be? So that is going to be from our second input coming in. That's going to be our file. And now the UV space, because we have already taken our primitive here and converted that into a 0 to 1 range into UV space, we're simply going to take our position and go straight in here. And then we'll just output that right into position. Just going to go up here and let's template that geometry so that we can see how that's working. So of course it's flattened because we haven't given it a Z component. Now let's just check if we are able to do that with UVW separately. And if we can't, then we're going to have to find another way to actually find the correct Z proportions of this object and set that. So I'm just going to try a vector to float and then see if wiring that into UVW will work. And so that does not work. So we are going to have to come up with another way of doing this. So for now, I'm just going to put this back. Before we move on, let's just make sure that this is working correctly. No, actually, this is good for now. Let's stay here. Let's figure out the Z component, and then we'll check it against the other prims. So we're going to save. And continue. So for the Z component, what we'll do essentially is find out what the surface normals of this primitive are, and we'll kind of do this almost extrusion to basically unflatten our piece of geometry here. So again, we'll use a primitive UV, and I'm just going to copy and paste that as well. Only this time I want to get the normals from our primitive. Now I want to find out what the Z component of our position is, so I'm simply going to press tab and type vector, and grab a vector to float so that we can extract just that Z coordinate. And let's put these here first. So when we want to do extrusions or we want to do displacements, essentially what we need is a direction, and then we multiply that by a magnitude. So the normal here is going to tell us the direction. We want to normalize that first and make sure that that has a unit length of 1 so that it's a standardized unit. And then we want to multiply that by the amount of displacement that's needed, which is going to correspond to our Z component here. And then we're simply going to add that into our position. So we're going to tab, add, There we go. So let's set this up, and we'll continue to work on this, but let's make sure it's working for everything now. We can just simply delete that out of here. And now we'll put another for each, grab a for each loop. And the same thing, we'll just turn off the piece attribute since we've already separated these faces. Just wire this right in here. This will be our second piece of incoming geometry, and then wire straight to here, and let's take a look. Just templating our geometry here. And you see now what we've done is we've made sure that we are sitting on top of each primitive here, and our object is deforming correctly so that it takes on the size of and dimension of each of our primitives that are coming in. So I do think that we need some adjustment for the Z component, because it would be nice if this felt like it kept proportion so that it doesn't stretch vertically like this. And that's something that I think we'll go ahead and fix right after we save this file. Saving and then saving our file. All right, let's go ahead and fix the Z component here. So what we should do is take the area of the primitive into consideration for the Z scale. So we will go up here and we're going to remeasure the area. So I'm just going to put down another measure right here. I'm going to change that to area. Now going back into place on prim, we're just going to copy this primitive UV again. Change that to a float attribute and call that area. And then we'll grab the square root of that, just like we did before, pressing tab, typing square root. And then we're just going to wire this right into our multiply. And now we should see something that looks pretty good. Let's test this by just putting a sphere here instead of a torus. Might be a little easier for us to judge. So I'm going to change that to polygon. We'll go to 4 for the frequency and just put that right here. So it's going to be hard to judge on the ones that are not square, but anything that is square, we should see something that looks like a perfect sphere. Just looking around here, and it looks pretty good to me. Okay, so that part is set. So let's go ahead and save this, and we'll save our file.